Hello. Have you ever wanted to create your own artificial intelligence or AI application, but thought it was too complicated? In this tutorial, we will show you a simple way to do exactly that using a tool called Gradio. We're going to build a do-it-yourself image captioning application that uses Hugging Face libraries, and we will run it using Docker. Through a Docker-based interface, we will connect this application to a runtime environment. While you can run this on your local computer, what makes this especially exciting is running it on a cloud-based Docker runtime. For example, a service called Cloud Run, which is provided by Google Cloud, will take your Docker container and run it in a production-grade way. It's important to note that we're going to do this in a way that works with different cloud providers. For instance, if you use Amazon Web Services or AWS, you can think of AWS Fargate as the similar service that would work just as well. We will also show you how to customize and extend this Gradio concept so you can develop and publish your own data and AI applications. Let's begin by opening a new Google Cloud project and setting up an editor to do our development work. You can use any development environment you prefer. We'll start by creating a file called app.py. To make this work, we need several libraries. First, we need the Gradio module. To handle the process of converting images to text, we'll use the Hugging Face Transformers library, which uses a PyTorch model. We also need to perform image manipulations, so we'll use the Pillow library. The next step is to create what we call a captioner using a transformers pipeline, specifically an image-to-text pipeline that uses a suitable model. We should explore the Hugging Face hub to find the right model for our needs. When searching, look for image-to-text models and select one of the captioning models. The Salesforce BLIP models will work well for our purpose. After checking the files, we can see that the largest model is about 2 gigabytes in size, which will work nicely for our needs. After selecting our model, we need to write a straightforward function that will generate captions for our images. The process is quite simple. First, we load the image using the Pillow library, then pass it through our captioner, and finally return the result. Thanks to the Hugging Face Transformers library, it really is that uncomplicated. Next, we'll create our Gradio demo interface. We need to think about what we want users to see when they use our application. The input will be an image, and then the output will be a text box that displays the caption. We'll also add some helpful additional information like a title and description to make the interface more user-friendly. With our captioning functionality defined and our Gradio application set up, we need to install our dependencies. These include Gradio, Transformers, PyTorch, and Pillow. We'll install all of these using pip installation commands. As we download these packages, it's a good practice to pin their specific versions. When we try to run our application for the first time, we encounter a small problem. There's an issue with TensorFlow Keras. This is an easy fix. We just need to install it with another pip command. While the installation is running, you'll see some download progress bars. These are a good sign because they show that we're successfully downloading the Salesforce image captioning model, which is about 2 gigabytes in size. After the installation completes, we get a local URL where our application is running. We can use the web preview feature to check it out. To test our application, we'll try using an image from Wikimedia Commons. Although the test image is quite large, we'll see if our application can handle it. When we first try to submit the image, we unfortunately get an error. Looking at the logs, we can see there's an issue with the image conversion step. As a solution, we can try removing this conversion step entirely. After making this change, we quickly reload our app, upload our image again, and resubmit it. This time, success. We get a proper caption for our image. Now we have a working web application that can perform image captioning. However, we're not going to stop here. Let's take this project one step further. While getting an application running in your own development environment is good, it's even more interesting to have the system working on a cloud runtime. We'll aim to create a production-grade deployment using Cloud Run. Before we build out our cloud deployment, let's understand what we need to do with the Docker image we're going to create. We'll use a service called Artifact Registry and push our Docker container there before uploading it to Cloud Run. Following best practices, we'll place both of these resources in the US Central 1 region. When Cloud Run deploys the service, it will automatically pull the Docker image from the Artifact Registry. For those using AWS instead of Google Cloud, this process would be similar to using AWS Fargate and Amazon's ECR or Elastic Container Registry service. Before we proceed with building and deploying our service, let's do a quick architecture evaluation. While a full production system might need features like input validation and rate limiting for safety, we'll keep things simple for this demonstration and skip those additional security measures. Let's start by creating our Docker file in the IDE. The first line will specify our base image. We'll use Python 3.12 since that's what we've been using in our deployment. We'll copy over our requirements file and install the dependencies just as we did in our IDE terminal. We also need to include our app file in the container. One important optimization we'll make is to pre-download our model during the build process. While this will make our container larger, it will prevent long startup times when we deploy the application. Finally, we'll add a simple CMD instruction to run our app. After setting up these basics, we can try building our Docker container. After successfully building the container, our next step is to run it. We'll make sure to use port 7864, the same port as before, and set up port mapping so we can access the application through our IDE's web preview feature. However, when we try to run the container, we encounter an issue. While the logs show the application running on a local URL, we're not getting the expected output when checking the container logs. The problem might be that we're not binding to the correct IP address. We can fix this by setting the server name to 0000 and explicitly setting the server port. While this might not be the root cause of our problem, it's worth trying. After rebuilding the application with these changes and running it again, we see that this solution works. Our Docker application is now running smoothly, and we can test our image-to-text caption generator one more time before moving on to the actual deployment. When deploying this type of application in a production environment, you would typically use an infrastructure as code tool like Terraform. This approach makes it easier to manage, control, update, and remove your systems when needed. In a Terraform setup, you would focus on defining both the artifact registry and Cloud Run resources in your configuration files. However, for this demonstration, we'll create everything directly in the Google Cloud Console to make it easier to follow along. We'll start with setting up the artifact registry. In the console, we select the US Central 1 region and choose to skip vulnerability scanning for this Docker repository. Next, we need to retag our demo image to point to the new repository and push it to Artifact Registry. Since we're using Cloud Shell Editor, this push process will be quick and straightforward. However, if you're using a local IDE or similar development environment, you'll need to set up authentication before you can push your container. Although the push takes some time, once we refresh the repository, we'll see our new application sitting in our artifact registry repository. Now we can move to Cloud Run to get our service up and running. We'll deploy a new service and select the application image we just pushed. There aren't many settings we need to adjust, but there are a few important ones. First, we'll allow unauthenticated invocations to make testing easier. We might also want to set the minimum number of instances to 1 to reduce cold starts. We definitely need to change the port specification since our application runs on port 7864. A crucial setting is the memory allocation for our application. The default half gigabyte of memory won't be sufficient to run this model effectively. We need to increase it to around 16 gigabytes, which matches what we used in our IDE and should provide similar performance. For applications experiencing long interference times, you may also want to increase the request timeout, but we should be fine with the default settings. After deploying to Cloud Run, we notice it takes about 6 minutes to complete. However, this timing is somewhat misleading because the first deployment is always slower than subsequent ones. This is due to our large image size. At 5.3 gigabytes, it naturally takes time to pull into Cloud Run initially. Finally, we can test our application using its public URL. This is now a fully published machine learning application that we're sharing with the world. When we upload an image to generate a caption, we notice the upload is actually faster than when we ran it locally. This makes sense because we're now leveraging the cloud's superior performance capabilities. The caption generation time is quite reasonable for a public web application. This completes our deployment process. Users can now access a production-ready AI application that can generate captions for any image they upload. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all the code and diagram files in the description as well. Thank you very much for watching to the end, and please enjoy responsibly.